Hi everyone, コアラです。今日の英語で雑学は You know why ice is slippery? You're probably wrong. 氷がツルツルする理由、実はよく知られていません。科学者たちが議論中のこの不思議な現象に一緒に迫ってみましょう。では最後までお楽しみください。
Okay, Maya, easy one to warm up. Why is ice slippery?
Finally, a question I know. The pressure melts the surface a little, so there's a thin layer of water, and you slide on the water. Boom. Next question.
Wrong.
Excuse me?
Wrong answer. But, and this is important, it's not your fault.
It feels a little bit like my fault, the way you buzzed me.
The textbooks taught you that. Generations of kids all over the world memorized that exact wrong answer for a test and got full marks.
Okay, so if that's wrong, what's the right answer?
Nobody knows.
What?
Scientists are still arguing about it, right now, in 2025. There was a brand new theory just a few months ago, and researchers are throwing hands over it as we speak.
Hang on. We can land robots on Mars, but we don't know why I fall down on the sidewalk every January?
That is exactly the situation. So today, we're chasing one of the most embarrassingly everyday mysteries in all of science, through twist after twist after twist.
Buckle up, I'm guessing.
Buckle up, it's gonna get slippery.
Was that a pun?
It was the first of many. I'm so sorry. Let's give your answer a fair trial first. The pressure melting theory. It's got a fancy pedigree, actually. 1850, a physicist named James Thomson, older brother of the famous Lord Kelvin, says pressure lowers the melting point of ice, so it melts.
And let me guess, little brother Kelvin backed him up.
Ran the experiments himself. 2 physicist brothers, 1 theory. Adorable. Then, in 1886, an engineer named John Joly does the math. No calculator, no computer, just a pencil and raw confidence.
My favorite kind of confidence.
And calculates that a skate blade puts about 466 atmospheres of pressure on the ice, enough to drop the melting point to about minus 3.5 degrees Celsius. Water film forms under the blade. You glide.
That sounds airtight. I'm feeling vindicated.
Don't. Because here's the hole in it the size of a hockey rink. Pressure only lowers the melting point a few degrees. By Joly's own numbers, you bottom out around minus 3.5.
Okay, and?
So if this theory is true, skating should be physically impossible below minus 3.5 degrees.
But people ski at minus 20.
People wipe out on ice at minus 40. Researchers slip in Antarctica. By the logic of pressure melting, every Winter Olympics is held at a temperature where sliding literally cannot happen.
Somebody should tell the Olympics.
And to even hit that pressure, the contact patch under your ski would have to be unreasonably, ridiculously tiny. The numbers don't add up.
So my answer is?
Completely busted. We lost our lead suspect, and we're in Chapter 1.
This is the worst trial I've ever attended. Okay, new theory. It's not pressure, it's friction. You rug, it heats up, it melts, right? It has to be that.
Closer, but still not the main culprit.
Oh, come on.
When you actually measure it, a ski sliding at any realistic speed doesn't make nearly enough heat to melt ice. Warms it a touch. Not enough to make a water film.
I refuse to accept this. Give me the knockout punch.
Here's the knockout punch. You can slip on ice while standing completely still. 0 steps. 0 friction. Feet go out from under you anyway.
I have, in fact, fallen down while standing motionless. More than once.
It's a rare talent, truly, but it proves the point. If friction heat were the cause, a stationary person couldn't slip. They do. So friction's off the suspect list too.
Both suspects cleared. The case is going cold.
Pun.
Pun intended, yes. I'm learning from you. It's a disease.
So let's rewind. Same year as pressure melting, 1850, the legendary Michael Faraday is quietly saying something totally different.
What's his angle?
He says the surface of ice has a thin film of liquid on it at all times, even below freezing. No pressure needed, no friction needed.
Wait, so the ice is already wet? Just sitting there?
A little bit, yeah. First person ever to poke at what we now call pre-melting.
That's brilliant. The scientific world must have loved him.
They ignored him for nearly 100 years.
100? This is Faraday, one of the greatest experimentalists who ever lived.
Left on red for a century. His idea was just too early.
Science is a cold place.
Fittingly. But he was right. We call that layer the quasi-liquid layer now. And the reason it exists is beautiful. A molecule deep inside the ice is surrounded on every side, locked in the crystal, can't budge.
Right, packed in like a crowded elevator.
But a molecule on the surface has nothing above it. One side is wide open, so it doesn't fit snugly into the crystal cage. It's loose, wobbly, a soft, slidey zone just a few molecules thick.
So you're telling me
ice is already sweating before you ever step on it. It's been sitting there, preloaded to make you fall, just waiting for you to show up.
the ice has been plotting against me. I knew it.
Now, present day. Scientists get their ultimate weapon, the supercomputer. They can simulate every single atom on the ice surface, watch it move.
Full surveillance, molecule by molecule.
So a team in Madrid hauls all three suspects back in. Pressure, friction, pre-melting. And the verdict comes back,
Don't tell me.
they all did it.
They all did it? That's the detective show ending where you throw the remote at the TV.
Near the melting point, the pre-melted layer's already doing the work. Add weight, pressure thickens it. Slide fast in the cold, friction chips in. All three at once, in different amounts depending on conditions. No single mastermind.
A group project. The ice did a group project to make me fall.
And then a team in Amsterdam zooms in even closer on how the surface molecules actually move. Turns out the water molecules right at the top keep swapping which neighbors they hold onto, and they roll across the surface at high speed.
Rolling.
Like the ice surface is paved with invisible, microscopic marbles. You think you're walking on a solid floor. You're actually walking on a molecular ball pit.
I'm walking on a ball pit. No wonder. Case closed, roll credits, right?
You'd think.
Why'd you pause like that? I don't like that pause.
Just a few months ago, a team at Saarland University in Germany publishes a new theory in a major physics journal. And it basically says,
Says what?
hold on, is the ice even melting at all?
I'm sorry. We spent 4 chapters on melting.
Their simulations show when something slides on ice, the act of sliding itself physically smashes the neat crystal structure. The orderly rows of molecules get scrambled into a disordered mess, and the longer you slide, the thicker that scrambled layer gets.
So it's not melting from heat.
It's getting wrecked by motion. Which is huge, because that finally explains slipping at -40. Even in absurd, near absolute zero cold, if you slide, the ice slides.
Because the sliding itself does the damage. Temperature doesn't even matter.
Exactly. The trigger's a tiny electrical tug between the molecules in your shoe and the molecules in the ice, and that disorders the surface. They gave the paper a slick title, too, Cold Self-Lubrication.
Meaning?
The ice doesn't wait around to be melted from outside. The instant you slide on it, it grinds itself down and makes its own lubricant.
The ice is sacrificing itself to take me down. That's commitment.
And barely any sacrifice, honestly. The amount it wears away at minus 10 degrees is less than the year-round erosion of Niagara Falls. Ice is quietly tough.
Respect. Okay, hit me. After all of that, which one is the real answer?
We don't know yet.
Leo,
I know.
Leo, we are 6 chapters in.
As of late 2025, the scientists are full-on brawling. The Madrid researcher says, I buy the new theory, but that structure-wrecking thing only happens at high speed. The new theory team says, no, it happens slow too. The Amsterdam team rides in going, we support the new theory, it matches our experiments.
So even the experts are slipping around on this. That one was on purpose.
I'm so proud. And one of the new theory researchers said it straight. It might be a combination of these, or a few of them, or it might be something we don't even know about yet.
Over 170 years. Supercomputers. And the official answer is a few things, probably, or maybe a mystery thing?
You've got to respect the honesty. Step back for a second, though. Ice is slippery. Everyone knows it. Everyone's experienced it. Skating, skiing, the glorious sidewalk faceplant, it all runs on this one thing. And we still can't say for sure why.
Which is kind of wild, right? We assume familiar means understood.
But it's usually the opposite. The most everyday stuff is exactly what nobody can explain when you look up close. There's a whole 170-year mystery sitting right under your boots that still hasn't been...
Don't.
Melted away.
You waited the whole episode for that.
I did. Worth it.
So look, next time your feet shoot out from under you on a winter sidewalk, don't be embarrassed. You didn't just fall.
You faceplanted on top of a puzzle the greatest minds in human history still haven't solved.
Stand tall. That's cutting-edge science.
See you next time.
On Yverse.
コアラの英語メモ
Mystery. Mystery.
Buckle up. Buckle up.
Cautionary tale. Cautionary tale.
動画のどこに出てきたか探してみてくださいね。ご視聴ありがとうございました。チャンネル登録よろしくお願いします。